Okay, good morning, grade 11s. Today we are learning about solving equations with rational exponents. Remember, rational exponents are exponents that are fractions. So for these types of equations, I think I'll just start with some examples. It's easiest to explain if we actually have some examples in front of us. So we'll just write examples. And guys, I obviously need you to be copying this down as I'm doing it. Please, you need this note in your books. So we would say examples. And then for the first one, we are solving for x. And we have x to the power of 3 over 2 is equal to 27. Now, obviously, when we are solving for x, we are wanting just x to the power of 1, in fact, equal to a number. So if we have just x equals something, then we've obviously solved for x. So in a sense, we want to try and get rid of this exponent, which is 3 over 2. We want to try and cancel it out. Now, I don't know if you guys remember this exponent law, but the one that says that if you have an exponent inside a bracket and outside a bracket, what would you do with those two exponents? You would multiply them together, right? That is one of the laws of exponents. So we are going to use this law, and what we're going to do is we're going to raise this side of the equation to an exponent that if we multiply it by 3 over 2, it would give us 1, because that's what we're wanting. We're wanting x to the 1. So I'm going to say that again. We're going to raise this whole left-hand side, in this case, to an exponent. So we're going to put this in brackets. We're going to raise it to an exponent so that if we multiply those two exponents, we would get an answer of 1. But now, because this is an equation, whatever we do on the one side, we would have to do on the other side as well. So hopefully you guys can kind of figure out that in order to get 1 from your product, you would have to times 3 over 2 by 2 over 3. All right, because if you multiply these two together now, the 3's are going to cancel out, the 2's are going to cancel out, you're going to be left with 1. Now, like I said, you can't just do it on the one side, you would have to do it on the other side as well, because it is an equation. So here, now you're going to say, okay, we're applying this exponent law. 3 over 2 times 2 over 3 is 1, so we're left with just x. Now we need to be able to figure this out without the use of a calculator. Now, what I would suggest is that we look at the denominator of this fraction. And just the reason for why we have to be able to do this without the calculator is that often they say in the expression or in the question, without the use of a calculator. If they don't, you could obviously just type this into the calculator. You could just say 27 to the power of 2 over 3, and you'll get your answer of 9. All right. What we are going to have to do in order to do this without the use of a calculator, we're going to have to write 27 with some kind of exponent, not with some kind of exponent, but with an exponent that will cancel out the denominator of our fraction. So what we're actually going to do is we're going to write 27 as 3 to the power of 3, and then raise that. Remember, it was originally raised to the power of 2 over 3. Now, what happens here? What is 3 times 2 over 3? The 3's are going to cancel out, and we're just going to be left with 2. So here we are actually going to get a much easier number to work with. Those 3's cancel out, so we're left with 3 squared. So our answer is 9. Okay, sorry about this light there. It's just the sun coming in through the window. The light is a bit weird today. All right, so we're going to do another example. We're going to see what happens if we do number 2. Again, we are solving for x. So we get x to the power of 5 over 3 in this case is equal to 32. Again, we see that we have a fraction in our exponent. We want to get rid of that fraction. So we're going to multiply it by 3 over 5, because 5 over 3 multiplied by 3 over 5 will give us 1. In order to multiply the exponents together, we have to put this original left-hand side in a bracket and raise the whole thing to the exponent. Do we notice that the exponent that we're raising it by is the reciprocal of the original exponent. What does reciprocal mean? It's just when you have a fraction and you swap the numerator and the denominator around. So if you have 5 over 3, then the reciprocal of that would be 3 over 5. Okay, so that's what we're going to have to raise it by every time. And then we get 32, and that we now also have to raise to the power of 3 over 5. Now the 5's cancel out, the 3's cancel out. We're left with x to the 1, which is just x. And now this side, we need to figure out what this is without using a calculator. So if we look at this denominator, it's 5. Can I write 32 as something to the power of 5? So that the 5 of this exponent will then cancel out the 5 in my denominator. I'm sure you all know that 32 is the same as 2 to the power of 5. So we raise that then to 3 to the 5. And then those 5's will cancel out. We're left with x equals 2 cubed, which is 8. And guys, obviously, let's just check it quickly in our calculators. 32 to the power of 3 over 5 is, in fact, 8. You can see it there. All right. Now, the next example is one that you wouldn't necessarily use this method for. I just want to show you, just want to illustrate something important to you. If we have something like x squared is equal to 9, right? I know that this exponent is not a fraction, but we could write it as a fraction, right? 2 is the same as 2 over 1. So we could technically write this as x to the power of 2 over 1, and then it does have a rational exponent, a fractional exponent. I just want to illustrate something to you guys. If you see this, there are actually 3 methods now that you could use to solve this. The method that I have been kind of expecting you guys to do is to recognize that it's a quadratic equation. So we take everything to the one side, make it equal to 0. From there, we would factorize. This is a difference of 2 squares, so we would factorize it like so. And then we would make each bracket equal to 0. So we would get 2 answers from this, right? We would get -3 or +3. So that's one method. Or you could do it differently. You could say if you have x squared equals 9, you could just take that square over. What is the opposite of squaring something? Square rooting it. But now in order to get these 2 solutions, it's very important that we end up with 2 solutions. Remember, if you have a quadratic equation, you are supposed to get 2 solutions for x. Right? Those solutions might be the same number, so 2 of the same number, but basically you need to get 2 answers. So what you would have to do here is you would actually have to do the plus minus the square root of 9. You probably wouldn't write square root of 9, but I just want to show every step. So then you would get x is equal to plus or minus 3. So I hope that it's clear from this example, these 2 methods that I've shown you now, that we all know already, we have used these methods before, that we are supposed to get 2 answers in this expression, or from this equation rather. Now, if we wanted to use this method that I've shown you up here, you would actually have to, if you have x squared equals 9, you would have to now, in order to cancel out that 2, you would have to raise it to the power of a half, right? Because 2 times a half is 1. The 2's are going to cancel out there. So then you would get your exponent of 1. But now you would have to do the same thing on the other side, right? So here you would actually have to now do a plus minus 9 to the power of a half. That is very important, guys. As soon as you raise it to the power of a half in this case, you have to add that plus minus. Because we know that we have 2 x values, 2 answers for this. So 2 times a half here is 1, so x to the power of 1. And this is then plus or minus. Now 9 to the power of a half, you could use your same method that we did previously. You could write 9 as 3 squared to the power of a half, in which case those 2's are going to cancel out. So then you also get your plus or minus 3. Now, guys, I'm not expecting you to use this method if you get x squared equals 9. Not at all, all right? You would use one of these 2 methods, I'm sure. You would either use your getting everything to the one side equal to 0 and then factorizing, or you would do your plus minus square root method. That's perfectly fine. You will still get full marks for that. This method, in fact, probably wouldn't even be on the memo if you got something like this. It would be fine if you use this method, but I won't expect you guys to use this method. The only reason for why I'm showing you this method is because when we have a certain type of fraction as our exponent, and when we are using this method that I've explained up here and this third method here, we are going to have to know when we must put a plus minus in front of our number that we are raising to whichever power. Okay, so that is very important. And if we look at the exponent that we have here, the exponent is 2 over 1, 2 over 1, 2 over 1. Basically, we have an even numerator, right? So what we're going to practice now in the next couple of questions is when our exponent has an even numerator, the original exponent in the original question, when it has an even numerator, that means that we are actually taking the square root or an even root, which means that we have to put a plus minus in front of our answer. Right. I'm just going to close these blinds a bit, see if it helps with the light. Okay, that's better. All right, so let's make a little note of that. So, original exponent has an even numerator, then plus minus. And guys, the step in which you do the plus minus is also very important. I'm just going to lift that up a bit. Sorry, now it's a bit dark in this room. The step in which you put that plus minus is also very important. It is always the step where you are actually raising both sides to that exponent. Guys, you just did rational exponents before this lesson. And do we remember that when you are saying anything to the power of a half, it's actually the square root of that thing. So it's here. This step is actually the same as that step. I want you guys to recognize that. Plus minus the square root of 9 is the same as plus or minus 9 to the power of a half. Because remember your rational exponents, anything to the power of a half is the same as the square root of that thing. So this is actually the same step. You have to, if you're using this method, you have to put the plus minus in front of whatever number you have the square root of them. All right, so you can't say x is in the square root of 9 and then only in your answer say plus or minus 3. You have to already put that plus minus when you take the square root, which is why it's very important that we do this plus minus essentially when we're taking the square root, when we are raising that number to the power of a half. Okay, so that is the step where you have to start writing it. And then you need to write it all the way through while you are simplifying as well. Okay, we're going to do another example, a couple actually, just so that you guys can get used to this. So for number 4, sorry, I just opened the blinds a little bit again, trying to get the balance here. Okay, so we are solving for x, so solve for x. We have x to the power of negative 2 over 3 is equal to 9. Okay, so now we can obviously see that we have a fraction in our exponent. And please, we need to notice immediately that our numerator is even. So that means that we are going to have a plus minus as soon as we raise both sides to that exponent. The other thing that's different here is that our exponent is actually negative. So now we just need to remember that we are still aiming to get to x to the power of 1, x to the power of positive 1, in fact, right? X to the power of 1. So now what am I going to have to multiply negative 2 over 3 by to get positive 1? I hope it makes sense to all of you that we're going to have to raise this and the other side now to a negative exponent. So we're going to have to do this. We're going to have to say x to the power of negative 2 over 3. Now I must raise that to a negative 3 over 2. Because remember, we're wanting x to the 1. A negative times a negative will give us a positive. 2 and 2 will cancel out. 3 and 3 will cancel out. So there I'm going to get my positive 1. All right. So we're going to get on this side. Now we also need to remember, because we had an even numerator, as soon as you're raising both sides to that exponent, you have to plus minus. 9 to the negative 3 over 2. All right, guys, just to reiterate, the reason for why we are doing a plus minus here is because our numerator is even, yes, but if you were to write this now in third form, in root form, right, this would be, well, because it's negative, it's a bit difficult. You could actually write this as 1 over 9. Let me do that rather. To the positive 3 over 2. Okay, I just don't want that negative. But now, this 3 over 2, if we were to take this as our, if we were to write it in third form, we would actually get the square root. Remember, the denominator goes on the outside of 1 over 9 to the power of 3. And when you are moving a square root, we saw it up here, you have to do a plus or minus. Okay, but the easiest way to spot that right from the start of the question is if you see that your numerator is even. Okay, it's very, very important, guys. So now here we're going to have x to the 1 is equal to plus or minus. Now to get rid of this 9 and actually the fractional exponent, we're going to write 9 as 3 squared so that this 2, this exponent, will cancel out the denominator in the fraction. All right, so there we get plus or minus 3 to the negative 3, which is now plus or minus 1 over 27. Right, let's check that. Let's see, 9 to the power of negative 3 over 2, we do get 1 over 27. Guys, I also just want to say again, if the question doesn't state that you are not allowed to use a calculator, you would just have this step, type it into the calculator and get your answer. But note that the calculator doesn't give you the plus minus. All right, you need to remember that. Okay, let's see. I'm just going to do one last example quickly, number 5. And then this lesson is done. So number 5. Again, solve for x. We are doing 5x to the negative 2 over 5 is equal to 20. All right, this question is just slightly different from the others because now we have a coefficient on this side. We have a number in front of the x. Remember, when we're solving for x, we just want x equal to a number. So we need to get rid of this 5. So just like in any other, sorry, my door slammed from the wind. Just like in any other equation, if we just had 5x equals 20, you would all know to move that 5 to the other side, right? Or to divide by 5. So now it's the same thing on this side. I'm multiplying the x term, the x variable by 5. So the opposite of multiplying by 5 would be dividing by 5. So I'm going to say x to the negative 2 over 5 is equal to 20 divided by 5, which is 4. Do we again notice that we have an even numerator? Right, so now to cancel out my exponent of negative 2 over 5, I have to raise it to the power of negative 5 over 2. And because my original numerator was even, I have to say plus or minus 4 to the negative 5 over 2. Again, I'm doing that plus or minus because if we were to write this in third form, just again to make that exponent positive, I'm just going to change 4 to 1 over 4. And then we have positive 5 over 2. And this is then the square root, because my denominator is 2, of a quarter to the power of 5. And we know that if we move a square root, so if we're moving like a square over and we're square rooting the other side, we have to do a plus minus in front. All right, so here we have plus or minus 4. I'm going to write as 2 squared so that it can cancel out that 2 at the bottom. And we have negative 5 over 2. Now the 2's are going to cancel out. Sorry, this is x. I forgot to write that. Because negative times a negative is a positive. The 2's will cancel out. The 5's will cancel out like so. So we're left with x is equal to plus or minus 2 to the negative 5, which I hope you guys know is 1 over 32, right? 2 to the 5 is 32. So to make this negative exponent positive, you would move it to the denominator. The exponent will then become positive 5, and 2 to the positive 5 is 32. Let's just do a check again. 4 to the negative 5 over 2, and we get 1 over 32. All right, so that is how you would solve these equations with rational exponents. I would like you to do exercise 8. On page 12. And I want you to do all of them. You must just do numbers, let's say 3 to 9. Okay, I will be back on Monday. I have tonsillitis, so I've been booked off for yesterday and today. So I'm not at school, but I am going to be back on Monday, and then we need to carry on with new work. So please, guys, you need to rewatch this video if you're not understanding how to do the homework. And literally, you're going to follow the exact steps that we've been following in all of these examples. So you need to look back at these examples if you are getting stuck. Thank you. Have a lovely weekend.